looking at proportionality theorems, all right? First of all, if we have parallel lines, they're going to create some proportions. They're going to create some pretty consistent patterns for us, consistent facts too. So here, if we have a line parallel to a side of our triangle, and that line's anywhere amongst our triangle, intersecting the other two sides. I don't care where it is, all right? It's going to create proportional segments on each side. Notice here, this isn't necessarily a mid-segment, though a mid-segment would follow this situation. But this parallel line could be anywhere. It could be up here. The parallel line could be way down here. I don't care where that is. It's just somewhere on this triangle. Well, XA is to AY as XB is to BZ. All right, it's pretty easy to use. Let's check it out. Find the length of AE. I'll label that X. Well, notice I have a parallel line to the third side of a triangle. I know this is going to split it proportionally. 2 is to 3 as X is to 5. It's that simple. We cross multiply. That's 10 equals 3x. X equals 10 thirds. Boom. Well, the converse is also true. If we see a line on our triangle, and it looks kind of parallel, and you're thinking, well, maybe this is. Well, if you want to determine if it's parallel or not, you can check to see if it's splitting the pieces proportionally. If it's splitting the pieces proportionally, well, it absolutely is a parallel line. So is ST actually parallel to PR? It looks like it might be. Well, 3 is to 8. We want to know, is that as 2 is to 7? Is this true? Well, first of all, you might know a little thing about math, and you might know that 3/8 does not equal 2/7, so you could also already see that does not equal. We also could check by cross multiplying. 7 times 3 is 21. 2 times 8 is 16. Again, does not equal. If these were proportional, we could cross multiply and see they are equal. So, is it parallel? No. It is not parallel. Now, not just thinking about triangles, but thinking about lines in general, if parallel lines intersect transversals, they will divide the transversals proportionally. Okay, see the situation? We end up having 3 parallel lines here, and we're told that AC is to CE as BD is to DF. Okay, so let's check it out. Oh, sorry, we also have, if parallel lines cut by congruent segments on one transversal, they also cut congruent segments on all transversals. So what that means is that's just a more specific version of what I just said. If we know that these two are actually congruent to each other, it's been cut by these parallel lines and they're congruent, well, their ratio, their proportionality ratio is 1 to 1. So that means that these down here are 1 to 1. All right, we want to find the length of segment AB. Well, look at this. Over here, these are congruent segments when we have parallel lines cutting through these transversals. So over here, we know that these must also be congruent. I know that x plus 3 must equal 3x minus 1. So when I solve for x, I get 3 equals 2x minus 1, 4 equals 2x, x would equal 2, but we want to know the length of AB. That's this segment, so I'm going to plug a 2 in there. 2 plus 3 gives me 5. That segment would have to have a length of 5 units, whatever we're counting by here. Determine whether V or UV, WX, and YX are parallel when x equals 3. Alright, well, notice here that these two pieces are congruent. So that means that these segments must also be congruent. And if x is 3, I can plug that in. 4 times 3 minus 1 gives me 11 for that segment. 5 times 3 is 15, minus 3 gives me 12 for that segment. Well, in order for these lines to be parallel, they have to cut these segments proportionally. And 11 to 12 is not the same thing as 14 to 14. This reduces to 1 and this does not. So these are not parallel. Alright. Application. Perspective is a method artists use to make objects appear as if it's receding into the distance. If the fence posts are parallel, what is the length of AB? What's the length of AB? If EH is 22, all of EH is 22. I'm going to label AB as X because I know that's what we want to find. BC is 4. CD is 6. FH is 18. All right. Well, all the fence posts are parallel, so I see this as two pieces down here. We have this piece must be 4, and that piece must be 18 down there. See that? 4 is to 18. So I'm going to use that comparison. 4 to 18. That's the piece between the first two fence posts, and the piece between these last, because these are still parallel lines for us. So I'm using those 3 parallel lines right there. 4 is to 18 as X is to 10. 4 plus 6 gives us 10. So it's between the first two, between the second and the fourth, between the first two, between the second and the fourth. I can cross multiply this. 18x equals 40. Divide both sides by 18. 40 over 18 reduces, give us 20 over 9. I'm going to leave it like that. We don't have any units, but I mean, it's some kind of units here. All right, feet, inches, centimeters, whatever this is.